We'll introduce algebra in this lesson. We'll be looking at the laws of algebra and see how we can use them to simplify expressions. We'll expand brackets and go in the reverse direction and factorise. Let's have a look at this number puzzle. Think of a number, multiply it by 5, add 11, double that answer, subtract 2, divided by 10, subtract the first number you thought of, and your answer is 2. We'll see later on how we can represent that using algebra to find our answer as 2. So what is algebra? Algebra is generalized arithmetic. We use letters to represent some unknown quantities. So the rules of arithmetic can also apply to algebra. Usually we need to find some unknown quantity represented by some letter. Let's formalize some laws of algebra. We can add numbers in any order. 6 plus 3 is the same as 3 plus 6. And we can do that for any numbers, not just 3 and 6. So we can say any first number plus any second number is the same as the second number plus the first added in reverse order. The same applies to multiplication. 2 lots of 4 is the same as 4 lots of 2. And so again, we can say that A times B is the same as B times A, where the A and B can be any number. Does this also apply to subtraction and division? The associative law says that we can add numbers in any order. If we have 6 plus 3, that is 9 plus 4, we have 13. And if we start with 3 plus 4 to get 7 and do 6 plus 7, we'll get 13 there as well. And that'll work for any three numbers. So we can generalize that to A plus B added together first, and then add C is the same as adding the B and C first and adding that to the A. And the same applies to multiplication. As you can see here, we have a block of 2 by 4, so that's 8 blocks there, and we have 3 rows of those. And here we have a 4 by 3 block of 12 there, and we've got 2 layers of it. And either way, we will get 24. And this works for any numbers, so we can generalize that and put A and B and C as the three numbers. Will this apply to subtraction and division? For example, if we have 10, take away 3 and do that part first, 7 plus 2, we'll get 9. If we do the 3 plus 2 first, we'll get 5, and then 10 take away 5 is 5. So we got different answers, didn't we? What about division? Will it work for division? Try that out and see what you get. Again, we can see that with division, the order there is important. Like terms are those that have exactly the same letter parts. For example, 3m and 4m. They can be added together to get 7m. The two terms can be added because they both have a certain number of m's, 3m's and 4m's to get 7m's. But 3m and 4n are different amounts. We don't know what the m and the n are. They're different numbers. And so we can't combine them together. So to add like terms, we need to group them together firstly. And so we'll group the two x terms together there, the two y terms. Notice that the subtract goes with the 5x. It stays with the 5x. And when we subtract those, of course, we'll get 3x. And here we'll get 6y. The 8x and 6y can't be added together because they're unlike terms. Now don't forget that we don't know what the x's and the y's are, but we can combine the like terms because we know we have 8 lots of it and less 5 lots of it will give us 3 lots. And likewise here we've got 4 lots, and 2 lots will give us 6 lots. Here's an exercise in like terms. You might like to just pause the video and have a go at those now. How did you go with those? Did you get these answers? The 2x and the 3x gives us 5x. The 9 and 4 gives us 13xy. In the next one, we have a 4 and a 5 is 9x squared plus a y squared. The number there is equivalent to 1. We have 1 y squared there. We don't normally put the 1 in. In the next one, we'll combine the xy terms. We've got minus 4 plus 3 is minus 1. And 2x minus 3x will give us a minus x. Yeah, be careful here, the m cubed and the m are different, as is the mn. So if we look at the m cubes, we have m cubed there minus 4m cubed is minus 3m cubed. We've got 3m minus m is 2m. And we've got mn on its lonesome there. Next we have all z terms, so we can combine those. We can just do those from left to right. So that's a 4z minus 8 is minus 4z. Plus 2 is minus 2, and then minus 3 will give us a minus 5z. Let's now have a look at the distributive law. This is understood to mean 3 times 2 plus 4. So we start with the brackets. 2 plus 4 is represented here by 2 blue blocks and 4 yellow blocks, and I have 3 lots of them. So therefore I've got 3 lots of the blue blocks and 3 lots of the yellow blocks. That is, that I have to multiply the 2 by 3 and the 4 by 3 as well. And we can do that with any numbers, so we can represent this generally using the letters A, B and C, where A, B and C are any numbers. And to expand that out, we have to multiply the A by the B and add to that the A times the C. Let's have a look at an example here. So we've got 3m times 2m plus n. So what we need to do is multiply the number outside the 3m by each of the numbers inside. So 3m times 2m plus 3m times n. So that'll give us 3 times 2 here, and then an m times an m. We can reorder those because we can multiply numbers in any order. And of course 3m means 3 times m. And likewise with the 3m times n. So that'll give us a 3 2's a 6, m times m is m squared, and an m times n is just mn. So we'll write that answer as 3mn. Here's some practice at the distributive law. So pause the video and have a go at those, and we'll check the answers in a moment. How did you go with those? Let's have a look at the first one there. The 2x times the 3y will give us 6xy. 2x times the 4 is 8x. With the next one, we're doing 4 times 3 is 12. Y times y is y squared. It'll be minus now. And 4 2's are 8. xy. We'll normally write the xy in alphabetic order there when we've got a string of letters. Although yx is equivalent as well. Here we have m squared times an m. So we've got one m there, 2 of them, they're all being multiplied. So we've got 3 lots of m cubed, and 6 lots of m squared. Next we have a 3 that's negative, multiplied by 2 is negative 6x squared, and a negative 24xz, or subtracts 24xz. Got 3 terms here, so we'll need to multiply the 2x by each of those. So that'll give us 6x times x is x squared times y. 5 2's are 10x, and then a minus 2 7's are 14xy. And in the last one we have 4x squared y times an x, so we'll have an x squared times x is x cubed, and then a minus times a minus is a positive. 4x squared y times y squared is y cubed. We use the distributive law to expand brackets. Going backwards is called factorising. For example, if we want to factorise this expression, we want to put something outside the bracket. And of course, it is a 3, because if we expand that, we'll get 3 5s are 15, c, 3 2s are 6, minus 6 there. So to find our factor of 3, what we need to do is look for the highest common factor between 6 and 15c. Let's revisit our number puzzle. We think of a number and we'll represent it as x. Multiply it by 5 will give us 5x, adding 11, and then doubling that answer using the distributive law there. We multiply the 2 by the 5 and the 2 by the 11. Subtract 2 and simplify. We'll divide that by 10, so we're getting 1/10, again the distributive law of each of the terms there. And then we subtract the number we first thought of, so that's subtract x, and so our answer therefore is 2, regardless of what number we start with. So we've seen that the pronumerals or letters just stand for numbers. The laws of numbers also apply to algebra. Like terms have the same letters, and we can add and subtract them to simplify expressions. The distributive law tells us that we need to multiply the a by the b and the a times the c.